All right. I guess it's okay if we have a lot of questions. There's no rush today. Hey, so this is a golden opportunity. If you didn't do your homework, you should write it down, huh? Or you already feel guilty enough as it is. Okay, what's the first one? What do we got? Number 5. Find the derivative. So 4 minus x squared sine x. Okay, derivative. What's the derivative of 4? 0. Now this negative sign, there's several things you can do. You want to just throw it on the side like an unwanted pet, because that's like -1. Or some people do this, they put the negative with the x squared and then when you do the product rule. Or throw it on the side like an unwanted pet. What do you guys want to do? Throw it on the side. Okay, so throw that on the side like an unwanted pet. Now, I see a product here, so it's like that, yeah? What do you do when you see the product? You use the product rule. Derivative of the first, that's easy. Leave the second one alone. Then you leave the first one alone. Derivative of the second. Now, what's the derivative of sine x? There you go. That was last night's homework. And then all you have to do is distribute that minus sign, and that's your answer. Yeah? Just make sure you distribute that minus sign because you threw it on the side like an unwanted pet. Yeah. Number 7. Y equal 4 over cosine x. Now, yes, you can use the quotient rule, but how about simplify it to 4 secant x? Because don't we know the derivative of secant x? I hope by doing the homework you guys memorize it, because there's no notes on the test. You gotta memorize these things. So throw the 4 on the side like an unwanted pet, and then the derivative of secant x is secant x tangent x. Boom, finished. Okay, that was a strange one. Number 9. Okay, there's no way you're gonna get a problem that easy on the test. There's no way. Number 9, this one has potential. Did I assign number 10? No. Really? Anyway, I did that as an example. You guys probably forgot. This one has potential. We'll see if I like problems that you have to do simplifying. Well, I see a quotient here, so we need to use the quotient rule. Okay, who's got this one? Bly. Quotient rule, katize it.
1 plus cotan x times.
Wait, let me look at the chart.
Yeah. Negative.
Okay, low D high minus high. Okay, Bly, give me the D low.
Negative cosine squared.
Okay. All over denominator squared we go. Okay, you write down on the paper, you get half the points, the other half comes from simplifying. Well, hopefully, let's see what happens. So multiply out everything on the top. Negative cosecant squared x minus cotangent cosecant squared plus cotangent cosecant squared. I like that. Because these cancel out. That's good. So all you have is negative cosecant squared x all over 1 plus cotangent x quantity squared. You can't really do anything with that, so that's your answer, I guess. Yeah.
Could you factor out the negative cosecant squared?
Yeah, and then the cotangents cancel out. Yeah. So yeah, it's gonna come out either way. Yep. Just like eating strawberry Pop-Tarts or blueberry, doesn't matter. Just comes up. Number 11. It says, what is the what? Okay, have we forgotten already? Here's your position equation. It says compute the velocity and acceleration. So, how do you compute velocity? Okay, take the derivative. Throw the 5 on the side like an unwanted pet. What's the derivative of sine? Okay. And then acceleration. Take another derivative. Throw the 5 on the side like an unwanted pet. Negative sine. Okay, and then what else do we do? Describe the motion. Again, what does describe the motion mean? When is it moving to the right? When is it moving to the left? When is it speeding up? When is it slowing down? How do you answer all these questions? Make number lines for the velocity and acceleration. So here's the velocity. So cosine, come on. You don't even, you should know already. Let's see, cosine is a known graph, right? You know what cosine looks like. Okay, so why don't we just do it from 0 to 2 pi? Do they even tell you? It doesn't say. Okay, so I'm just saying, let's just do it from 0 to 2 pi, good enough. That's what cosine looks like. When is it 0? Pi over 2 and 3 pi over 2, above, below, above, plus, minus, plus. Now, negative sign. Negative sign looks like this, yeah? What? So acceleration. So when is sine 0? Here, here, and there. When would that be? 0, pi, and 2 pi, and then below. Just look at it. Below, above. See, you don't. These are known graphs. So you can answer all the questions. When is the particle moving to the right? When the velocity is positive. So from 0 to pi over 2, and then 3 pi over 2 to 2 pi. When is the particle moving to the left? When the velocity is negative. So between pi over 2 and 3 pi over 2. When is the particle speeding up? See, this is the question I'm going to ask. When is the particle speeding up or slowing down? How do you tell if it's speeding up? The velocity and acceleration have to have the same sign. So where do they have the same sign? Right there. They're both negative, right? From pi over 2 to pi, and then from 3 pi over 2 to 2 pi because they're both positive. When is the particle slowing down? When they have opposite signs. So right there, from 0 to pi over 2, and then from pi to 3 pi over 2. That's why you make the number lines and line them up. There's no way you can get the problem wrong unless you make a mistake. All right, because that problem is definitely, when you do the practice test, you will see. Okay, 23. What does that say? 11? We just did 11. So, okay, you guys are confusing me. 23. Write the equation for the tangent line and normal line. Come on, we know how to do this. When x is 3. Okay, what are the two things you need to write an equation of a line? You need a point and you need a slope. Well, that's the x coordinate. How do I find the y coordinate? You plug it in. What happens when I plug in 3? 9 sine 3. Now you can leave the answer like that, or you can take out your calculator and punch it in and give 3 decimal place accuracy. It doesn't matter. I would prefer to just leave it like that, because then that save time, right? Now, how do you compute the slope of the tangent line? The derivative. Now, I see a product, use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone, derivative of the second. So therefore, what would the slope be? You have to plug in the x value into the derivative to get the slope. So what happens when I plug in 3? You get 6 sine 3 plus 9 cosine 3. Now that's a number. If you want to punch it in on a calculator, you can, or you can just leave it. I like to just leave it. Some of you rather punch it in and just get like a 3 decimal place thing, whatever. So if this is the point and this is the slope, just point slope. Y minus 9 sine 3 equals this ugly thing times x minus 3. And then, how about the normal line? What is the normal line going to be? It's going to be the same thing, except what? What do you do with the slope? You negative reciprocatize it. So negative 1 over this ugly thing. Okay, 23, 31. Okay, 31. I'm telling you right now, this problem is on the test. It might not be in the practice test, but I don't know, students have problems, maybe it is, I'm not sure, but students have problems with this every year. We need to be able to do this, 31. I just put it on my BC test too, and all hell broke loose, that's what happened. Even though I told them it was on the test. Woo! So here's the graph. What is it? Y equal 4 plus. Do I have to do parts A and B?
Yes.
Woo! Okay, A is the easy one. That's not the one on the test. B is the one on the test. So what is part A? Write the equation of the tangent line at point P. Here's point P. Pi over. Okay, look. Write the equation of the tangent line. What are the two things you need? A point. We got it already. Now how do you compute the slope? You take the derivative. The derivative tells you the slope. So, okay, the derivative of 4 is 0. Derivative of cotangent, we just did it over there. Negative cosecant squared x. Negative 2, throw it on the side like an unwanted pet. What's the derivative of cosecant x? Baby?
Negative cosecant cotangent.
That's what I'm talking about. Okay, there's the derivative. So how do you compute the slope? You have to plug in pi over 2 into the derivative. That's the hard part, isn't it? Yeah? Okay, what is cosecant of pi over 2? Think, no, it's not undefined. Think of what is sine of pi over 2 and then flip it over. Okay, it's 1. So square it. 1, negatize it. Negative 1 plus 2 times cosecant of pi over 2, we just did it, it's 1. What is cotangent of pi over 2? Very good, it's 0. Now tangent of pi over 2 is undefined. See, undefined would be something like this, but what happens when you flip it over? You get 0. So it's 0. Oh, so that just goes, so you just get negative 1, but that kind of makes sense though. Doesn't that look like negative 1? Yeah. So now point slope it. Y minus 2 equal negative 1 times x minus pi over 2. Leave it. Good. Okay, that's too easy for a test. Part B though, this is a good one. Probability 1 is on the test. Write the equation of this horizontal tangent. Probably on the test though, I'm just going to ask you to compute that point. What is that point right there? Well, what is the slope of a horizontal line? So we want to know when is the slope equal to 0. Well, this is the slope. The derivative tells you the slope. What do you think I'm going to do? Make it equal to 0. That's right. When is the slope equal to 0? Now solve that equation. Now that's why you need to know trigonometry. How do you solve an equation? What do you do? Mr. Park, I don't like cosecant and cotangent. Well, what did your teachers teach you? When you have a trig equation and you have cosecants and cotangents, what should you do? Change everything to sine and cosine. That's probably, it's up to you. You don't have to. But most students don't like cosecant and cotangent. So change cosecant squared to 1 over sine squared. Cosecant is 1 over sine. Now what is cotangent? Wait, let me look at the notes. Cosine over sine. Okay, now what do you do when you have an equation with fractions? Multiply both sides by the least common denominator, which is sines. You know, I even told the BC students, I showed them exactly how to do it, and then they don't even do it on the test. And they're BC. Multiply this by sine squared. Multiply this by sine squared. The sines cancel out, you get 2 cosine x. And of course, if you multiply anything times 0, you get 0. 2 cosine x equals 1. Cosine x equals 1/2. Hey, that's a number I know. Now, when is cosine x equal to 1/2? You got pi over 3, you got 5 pi over 3, you got 7 pi over 3, you got negative pi. There's an infinite number of answers, but that's why you have to look at the graph. Look at this graph. This is the first time to the right of the y-axis when cosine is going to be 1/2. So when is that going to be? Pi over 3, that's right. So the coordinate of this point, the x-coordinate, is pi over 3. Does everybody see why it's not 5 pi over 3? Because 5 pi over 3 would be more down there. This is the first time to the right of 0 where that's going to happen. Now, how do I figure out the y-coordinate of that point? What do I have to do? See, on the test, this problem's going to be worth 6 points. I think I'll give you 4 points just for coming up with the pi over 3. You want the other 2? You got to give me the y-coordinate. How do I get the y-coordinate? You got to plug it back into the original. Every year, I don't know why that seems like the hardest part of the problem. What happens when I plug in pi over 3 into the original function? I'll do the first one, 4 plus, okay, who's got this one? Cotangent pi over 3. Hazam alam.
1 over right 3.
That's correct. Minus 2 times cosecant of pi over 3. Go!
Negative, wait, no, just kidding.
Cosecant pi over 3.
Secant
Just think
sine
sine pi over 3 and flip it over. So what is it? 2. Is that what you said?
Yeah.
Okay, that's correct. Okay, now we gotta simplify that. 4 plus 1 over root 3 minus 4 over root 3. 4 minus 3 over root 3. But isn't that just root 3? Isn't 3 over root 3 just root 3? Think about that. How about this then? 3 to the first over 3 to the half, subtract the exponent. Or how about multiply top and bottom by root 3 then? Okay, whatever, man, that's it. 4 minus root 3. Now on the test, I'm just going to ask you to compute that point, so that would be the answer. But in the book, they're asking you to actually write the equation of this line. So what is that line? It's a horizontal line. What's the equation of this line?
Y equals 4 minus
Yeah,
3.
y equals 4 minus root 3, that's right. Y equals a number is a horizontal line, right? Okay. I think I gave you another one. If I didn't give you another one to practice, then I would do this problem like 2 times before I take the actual test. But that's just me. 35. 35. Find the second derivative. Okay, you're gonna definitely see this on the test. I don't know. Yeah, it'll probably be something like this. Okay, so make sure you compute the first derivative correctly. What is the first derivative? Chalk. Chalk.
Negative cosecant x cotangent.
That's what I'm talking about. Okay, maybe you get 1 point for that. Maybe. Second derivative. Okay, well I see a negative sign. Are we going to throw it on the side like an unwanted pet?
Yes.
Okay, and then I see a product here. So you got to use the product rule. So negative, okay, derivative of the first. Okay, we already know that already, right? Because we did it just here. Negative cosecant x cos. What? Wait! We can't. Ah! We're videoing. We can't use that side of the board. Strike one! Oh, I forgot the number. 35. Otherwise, the people watching the video, they don't know what's happening. Okay, so negative cosecant x cotangent x. So it's now second derivative. Throw the negative on the side like an unwanted pet. And then we have a product, so we're going to use the product rule. Derivative of the first, which we just did. Leave the second one alone. Plus, leave the first one alone. The derivative of the second, which is this side. What are you talking? Derivative of cotangent.
Oh. Cosecant. Negative cosecant. Cosecant.
Yeah.
X.
Yeah.
No. Squared. X.
See, when you take the AP exam, I'm going to be there going, eh. No, you gotta know. You just gotta know. Okay. What do you want to do? Distributize the negative side or factor the inside of the bracket? Do something. Okay, factor. Okay, what can I factor out on the inside of the brackets here? Cosecant. That's it? How about negative cosecant? Because they're both negative. Okay, what happens if I factor out a negative cosecant? Cotangent squared. Look, I can factor. I took Algebra 1, 8th grade at King Intermediate. You guys gotta be, you guys went to Iolani probably, yeah? No. King Intermediate? Come on, I'm pretty sure King Intermediate is low on the totem pole. I'm pretty sure you're above me. Hey, are you somebody? You somebody?
That's your question.
Yeah, that's a trick question. That's nobody. So the only thing you can do is cancel out those negatives, right? So there you go. That's pretty much all you can do. See, I don't know if I don't know. Yeah, you are gonna compute second derivative and use the product rule and trig functions on the test, that's a definite. 36, oh, here we go. Oh, we need room. You know what? I like this problem, that is definitely gonna have to be on the test.
Oh,
What?
that's so hard. Sorry. I'm thinking out
Well,
loud.
then it should be on the test then, right? Now, let me ask you this before we start. Is this theta bothering you?
Yes.
No, the reason why the book uses theta, because they're preparing you to take derivative of polar functions. Remember polar graphs? See, but we're in AB. AB, we don't cover polar, but in BC we do. So since we're in AB, on the test, I'm just gonna put x's. Is that gonna help you? Really? Doesn't matter what variable is there? It shouldn't matter, right? And then what happens when you go to, like if you're gonna major in engineering, you have to take third semester calculus, multivariable calculus, you got x, y's, and z's. And you got theta, phis, and what's the other one? Rhos. It doesn't matter what letter, okay, but we're AB, I just put x. Okay, okay, first derivative, at least get the 1 point for the first derivative. Well, I see a product, I gotta use the product rule. Derivative of the first, leave the second one alone. Leave the first one alone, and what's the derivative of tan x? See, what? Mariama, derivative of tangent x.
Secant squared.
Oh, sounds like two people. Amazing. Okay, there you
I
go.
had to correct myself from I said that.
That's okay. Okay, there you go. I'll give you 1 point for that. Now, you want the other 5 or 4? You gotta do the second derivative now. Okay, I'll do the first one. The derivative of tangent is secant squared. Okay, now, Mr. Park, we never learned how to take the derivative of that. Yeah, that's right. So you know what you do? What is secant squared? Secant times secant. That's right. Now you have 3 things. Mr. Park, we never learned the product rule for 3 things. Well, if we didn't, then you know what you can do? Group them like that. So you have something times something. And then just use the product rule. Okay, but you know what? I'm just going to teach you the product rule for more than 2 things. It's the same thing, you just take turns. Derivative of the first. No, I know. Derivative of the first, I wanted you to tell me. 1. Leave the other 2 alone. Now, what do you think? Now take the derivative of the second one, which is secant x tangent x. Leave the other 2 alone. And you can probably guess what? Take the derivative of the third one, leave the other 2 alone. But if you're smart, what? No need write it. What am I gonna do? No,
Oh, 2.
just put a 2. What? Okay, look. Okay, let's continue then. Derivative of the third one, secant x tangent x. Leave the other 2 alone. But hey, that's the same thing as this, so that's why you got 2 of them. But that's okay. You don't have to. Just don't have to. Just do that. Okay, I will leave the simplifying to you because I think you can handle that. Yeah. Or no? No. What is secant x? I mean secant squared plus secant squared. 2 secant squared. What is gorilla plus gorilla? 2 gorilla. Secant squared x tangent. Oh, because there's an x there. Tangent x. Did I do that correctly? What can be factored out? 2 secant squared x. What's left? 1 plus x tangent x, and you nobody. That's the answer. Okay, so the product rule for more than 2 things, not that difficult. Just keep taking turns. That's all you do. Take turns. 37. Okay, this problem is on the test, but this is just a simple version of the one on the test. Come on, we've done this how many times? At least, I would say 5 times so far. Is there a value? Okay, why don't I just tell you how I'm going to state it on the test? Find the value of b so that the function will be continuous. How many times have we done that? That one we've done like 6 or 7 times. How do you tell if this is going to be continuous when x is 0? If you plug in 0 for x here and 0 for x there, you gotta get the same number so that they actually meet at the same point, otherwise it's not gonna be continuous, right? So what happens when I plug in 0 for x here? You get b. What happens when I plug in 0 for x there? Oh boy. You get 1. They have to be equal. So in order for this function to be continuous, b has to be 1. Now, what about differentiable? Differentiable means not just continuous, but smooth. Now, in order for a graph to be smooth, what has to happen? The left-hand slope and the right-hand slope gotta be the same. So how do I compute slopes? The derivative. So if it comes in a piecewise function, the derivative is gonna be a piecewise function as well. What's the derivative of that? 1, and that's a constant, right? B is 1, so it's just 0. So just 1 plus 0. What's the derivative of sine x? I mean, cosine x. Negative sine x. So this would be the left-hand slope. This is the right-hand slope. What happens when I plug in 0 here? Well, it's just 1. What happens when I plug in 0 there? You get 0. Is 1 equal to 0? No, so this function will never be differentiable. There's always going to be a sharp point there. That's because the left-hand slope is 1 and the right-hand slope is 0. See how there's like a sharp point? So this function will be continuous when b is 1, but it will never be differentiable because the left-hand slope can never equal to the right-hand slope. Okay, like I said, that was a little too easy. Don't worry, it's on the practice test. You guys will get it. 39. Find the 999th derivative. That's what I'm talking about. See, on the test it's going to be 2018 because you guys are class of 2018. Mr. Park, it's going to take me all day. Wait, 38? No, 39. Oh, sorry, I'm looking at the wrong problem. 39 is, 725th derivative. You got to get used to this notation now. Find the 725th derivative, or I'll just tell you now, it's going to be 2018, okay? So how do you think we're going to find it? There's a pattern. You think that I'm crazy enough that you guys got to do 725 derivative? Come on, man. Okay, what's the first derivative? Cosine x. There's got to be a pattern. What's the second derivative? Okay. What's the third? Remember, you have to put the 3 in the parentheses, yeah? To represent the third derivative. See, just again, I'm using different notation for the derivative. What's the third derivative? See, you guys got it. What's the fourth derivative? Sine x. And then, isn't it just going to start repeating then? Because sine x goes to cosine x, right? Oh, so this thing repeats every 4, Mr. Park. That's right. So if it repeats every 4, what can I do? Okay. Yeah, this is the kind to get on the SAT, yeah? 725 divided by 4. Well, 4 goes into 7 1 time, remainder 3. 4 goes into 32 8 times, remainder 0. 4 goes into 5 1 time, remainder 1. That's what you need, remainder 1. So what's the answer? Cosine x, remainder 1. Because, here's another explanation. First, second, third, fourth derivative. 5, 6, 7, 8, 9, 10, 11, 12. All the multiples of 4 are right here, yeah? So the closest of multiple of 4 to 725 is 724, right? So this is 724, and then 725. But I think that's like the fast way to do it. Just divide. I'm just pretty much doing your whole homework, aren't I? Okay, 44. Did I assign 44? Okay, well, let's do it then. The spring. Oh, okay, there we go. 44. True or false? 50-50 chance. Okay, the spring is bobbing up and down on the end of a spring so this is the position equation. So since it's going up and down, you might want to think of that as like y, since it's like on the y-axis. but it doesn't matter. The spring is traveling upward. Now, so remember, when the particle is traveling on the x-axis, how do you tell if it's moving to the right or to the left? You look at the velocity, right? If the velocity is positive, right. Velocity negative, left. So if it's moving up and down, what do you think? Velocity positive, up. Velocity negative, down. So they're asking what, 3 pi over 4? We need to compute the velocity. Well, if this is the position equation, what is the velocity? The derivative, which is, throw the negative 3 on the side like an unwanted pet, and then cosine p. So now plug in 3 pi over 4. I hope that's, I forget the number already. It's cosine of 3 pi over 4. Okay, negative root 2 over 2, which is positive 3 root 2 over 2. So since the velocity is positive, it's moving up. Of course, that's too easy for the test. I probably will ask you, is it speeding up or slowing down? Then what would you do? You gotta look at the velocity and the acceleration. So you would have to do the acceleration, which is negative 3 times the derivative of that, which is negative sine t. I'll just write it out, and so you get positive 3 sine t. So at 3 pi over 4, you get 3 times root 2 over 2, which is positive. I shouldn't do that. 3 root 2 over 2, positive. So if the velocity and acceleration have the same sign, speeding up. That would be on the test. 48. Multiple choice. Oh, come on. This is an insult to your loins. Right there. Your loins are insulted by this problem right there. Find the second derivative. Okay, make sure you get the first derivative. Now, I see a product. I'm going to use the product rule. Kawahara.
1 times cosine
Yeah.
sine x.
There you go.
Sorry. Times x or plus x cosine.
Okay, there you go. That's the first derivative. So use the product rule correctly. Now we're going to do second derivative. Okay, 1, no need to write the 1. The derivative of sine is cosine. And then I see a product over here. I'm going to use the product rule. Who got this? Miyashiro? Product rule, look at that.
1 times negative sine, wait no, cosine x plus okay, wait, I'm sorry.
Oh, I fell for it. You just paused so I wrote it. Okay, derivative of the first, leave the second one alone. Now leave the first one alone. Derivative of the second.
Negative sine x.
Okay, and then what's the only thing you can do? Gorilla plus gorilla is 2 gorilla. That's the only thing you can do. And then now, pick out the answer. Okay, I will. I need glasses. C. Okay, oh, I thought we were almost done, but now we got QQ. Thought we were gonna finish our good thing. There's no lecture today. We'd be in trouble, man. Q 1, 2, 4. How many times are your loins gonna be insulted before you just like, you know, just. If the tangent line of the graph of the function at the point 1, 6 passes through the point -1, -4, then what is f prime? Oh, I like this problem. I like this problem. So we have a graph that passes through the point 1, 6. Here's the point 1, 6. So I don't know what the graph looks like. I'm just gonna make up something. I don't know. Okay. Then it says it also passes through the point. So the tangent at that point also oh, this is kind of off. Also passes through the point -1, -4. See, look, what am I doing? I'm drawing a picture. So now, how do you compute f prime of 1? Now, what does that mean? What is f prime of 1? What is the derivative when x is 1? what is the slope of the tangent line when x is 1? Well, there's the tangent line. Is there a way I can compute the slope of that? If you know 2 points? Yeah, just go y minus y over x minus x. So y minus y over x minus x, that's 10 over 2, 5. See, but the problem is so much clearer when you draw the picture, yeah? Because some of you are reading it, and I just go write them on the board tomorrow. That's so sad. Number 2. That's okay, I don't mind that. That's why I get paid the big bucks. Cosine x plus tangent. Find the second derivative. I wouldn't be surprised if you had to find third derivative on the test. Okay, I'll do the first one. Negative sine x. Who's got the second one? Okay, that's too easy. Secant squared. That's too easy. We just don't go straight to the second. Now again, when you take the derivative of secant squared, the only thing we can do right now is to change it to secant times secant. And then product rule. That's the only thing we can do right now. However, next chapter we're going to learn a way to take care of that. But right now, this is the only way. So the derivative of negative sine is negative cosine. That's easy. And then I'm going to use the product rule here. Derivative of the first. Secant x tangent x. Leave the second one alone. Okay, let's see if we learned anything. Just put a 2. What? Okay, look. Derivative of the first, leave the second one alone, plus, now leave the first one alone, times the derivative of the second, which is secant x tangent x. Do you see when they're like the same thing, you can just put the 2? Because look, that and that are the same, so there's 2 of them. Okay, whatever, don't do it, just do this. Now you put the 2, and then, I think you can pick out the answer, yeah? A. That's because I can't see. And finally, number 4, what time is it? Oh gosh. I thought we were going to finish early. Yeah! 4. Okay, this is the last one. A particle moves along a line, so the position is negative t squared plus 2t plus 2. What is the initial position? Okay, that's it. Initial position. We did this on the very first day. How do you find initial position? Plug in 0 for t, so 2. That's where the particle starts, that's the position. Just plug in 0 into the position. Part B, find the initial velocity, so plug in 0 into the velocity equation. Well, what is the velocity equation? If this is the position. Negative 2t plus 1. So if I plug in 0 for t, you get 1. Okay, see. When is the particle moving to the right? When the velocity is positive. So here's the velocity. We need to make a number line for it. What makes that thing 0? What makes the velocity 0? 1/2. Plug in a number bigger than a half, like 1. Negative. And how do I know if this one's plus? Odd power, or you can think, well, the graph of that is a line with a negative slope. It goes that way, so it's above and then below, right? I mean, there's so many different ways to figure it out. I forget the question already. When is the particle moving to the right? Well, when the velocity is positive. Look at your number line. When is the velocity positive? From 0 to 1/2. How come it includes 0? Because at 0, the velocity is positive, therefore it's moving to the right. Although I probably wouldn't take off a point unless I do. I don't know. We'll just have to see. Just depends what mood I'm in when I'm grading. Find the acceleration. Come on, that's an insult. If this is the velocity, what is the acceleration? You take another derivative. Negative 2. Okay, that's just nonsense. And then E. Find the, oh, I like this one. Find the speed of the particle when the position is 0. I like that question. Okay, here's the position equation. How do I tell when the position is 0? Set it equal to 0. Now, how the heck do I solve that? Now, here's what you guys do. I've noticed this on your guys' work. Why do you want to try factoring when the first term is negative? You know what I would do? I would multiply both sides by -1. Now, that's just me. Because when my teacher taught me at King Intermediate, always make the first term positive. That way you don't make mistakes. So t and t, 1 and 2, minus plus. So tell me, when is the position equal to 0? At t equal -1 and t equal 2, but there's no such thing as negative time, right? So only when t is 2. So at t equal 2, they want you to find the speed. Now, you guys all here took physics. What's the difference between velocity and speed? Speed is the absolute value of velocity. So what is the velocity when time is 2? You plug in 2 into this equation and you get -3. But they want the speed. Speed is the absolute value of that. The answer is 3. Speed is absolute value of velocity. See how if you remember your physics, it makes this a lot easier, yeah? Question.
Oh, mine is B1. Or, oh no, it's the never mind.
Because they asked for the initial velocity, right?
Yeah.
So that means plug in 0 into the velocity equation. So 0 plus 1. Woo! That was a marathon. Yeah.
Do you care if we have units or not?
No, don't worry about units. Unless they ask for it.
Okay.
So, yeah, don't need to worry about it. Yeah. Well, yeah, you can just write speed or just write 3. That's the question they're asking. Okay. Oh, that's gonna take a while to upload the video. That's pretty long. Alright, the bell rings in 2.5 minutes. Yeah, you guys can just go already.